Find the derivative of g of x equals the square root of x times 3x squared plus 6x minus 4, A, by using the product rule, B, by taking the product first and differentiating the result. For part A, g of x is the product of two expressions. The first, square root of x, the second, 3x squared plus 6x minus 4. I'm going to rewrite the first, square root of x, as a fractional exponent. It is x to the first power and second root, or square root, so x to the 1/2, times, and I will leave the second expression alone, 3x squared plus 6x minus 4. The derivative, g prime of x, using the product rule, will be the derivative of the first, x to the 1/2, which will follow the power rule. Bring the power down and subtract 1 from it, or 2/2 in this case. The derivative of the first times the second left alone plus the first left alone times the derivative of the second. Now the derivative of the second, since we have terms that are added or subtracted, we can work each of those individually. The first term will follow the power rule. Bring the 2 down. 3 times 2 is a 6. X raised to the 2 minus 1, which is 1. The second term is constant times x. The derivative will be the constant. Derivative of 6x will be a positive 6. The third term is a constant with no x. The derivative of that will be a 0. So our derivative g prime of x is equal to 1/2 x to the 1 minus 2, negative 1 over 2. We're going to be distributing that in. When you distribute and you multiply x's with different exponents, you add the exponents. Since I'm about to add the exponent of negative 1/2 to the other exponents, I'm going to rewrite these over halves. So instead of 3x to the 2, I'm going to write it as 3x to the 4 over 2. And instead of 6x to the 1, it's 6x to the 2 over 2. Minus 4 doesn't have an x. We'll just leave it the way it is. I'm also about to distribute the x to the 1/2 in to 6x plus 6. I will rewrite the 6x to the 1 as 2/2. The 6 here doesn't have an x. I'll just write it as 6. We can now distribute. I'm going to start by distributing this into all three of these terms. The first, we will take 1/2 times 3, which is 3/2. X raised to, and now you add the exponents, negative 1 plus 4 is a 3/2. The next term, we will have a 6 times 1/2, which is 6/2, and x raised to the 2 minus 1, or 1/2. The next term we will have negative 4 over 2. That has no x with it, so you just multiply it with the x to the negative 1/2. We're now going to distribute the x to the 1/2 into each of these terms. The first one will be 6x to the, add the exponents, 1 plus 2, 3/2. The second term, the plus 6, doesn't have an x with it, so we just multiply by x to the 1/2, so it'll just be 6x to the 1/2. We have some like terms in there. We have 2x to the 3/2, and we have 2x to the 1/2. There's only one x to the negative 1/2, but we will want to combine like terms together here. 3/2, x to the 3/2, plus 6 over 2 is 3, x to the 1/2, minus 4 over 2, which is negative 2, x to the negative 1/2, plus 6, which I'm going to rewrite over 2 so I can combine the 6x to the 3/2 and the 3/2 x to the 3/2, the 2x to the 3/2 terms. Let's write that as 12 over 2, x to the 3 halves, and then we have plus 6x to the 1 half. Combining like terms, I have two x to the 3 halves powers. I have a 3 halves and a 12 halves. 3 plus 12 is 15 halves. X to the 3 halves. There are two x to the 1 halves, a 3 and a 6. 3 plus 6 is 9, x to the 1 half. And we have 1 x to the negative 1 half. Now when I write this one, I'm going to move that x to the negative 1 half to the denominator, so I can call it positive 1 half. The negative 2 does not move and stays in the numerator. So negative 2 over x to the 1 half. X to the 1 half is the square root of x to the first power, or just square root of x. I will rewrite each of those then to be the square root of x. I'll leave the first term alone, and I have 9 square root of x minus 2 over the square root of x. And there is our derivative. Now for part B, we're going to find the derivative by taking the product first. I have the product of two expressions. First, square root of x. Second, 3x squared plus 6x minus 4. I'm going to rewrite the square root of x to the first power as x to the first power, second root x to the 1 half. Since I'm going to distribute this in, I'm now going to rewrite 3x to the 2 as 3x to the 4 halves, and the 6x to the 1 is 6x to the 2 halves, minus 4 doesn't have an x with it. That'll make it easier to distribute because we add exponents. The first will be 3 times 1, which is 3, x to the 1 plus 4, which is 5 halves. The next one will be 6 times 1, which is a 6, x to the 1 plus 2, x to the 3 halves. And then minus 4 does not have an x with it, so the x just distributes with that negative 4x to the 1 half. These terms are added or subtracted with each other. We can therefore take the derivative of each of them separately and add or subtract the results accordingly. G prime of x will be the first, a power rule. Bring the 5 halves down and subtract 1 from it. I will call that 2 halves. The second term will follow the power rule. Bring the 3 halves down, x raised to subtract 1 from the exponent. I will call that 2 halves. The third term will follow the power rule. We'll have minus 4, bring the 1 half down, x, and subtract 1 from it. I will again call that 2 halves. Three times 5 halves is 15 halves. X raised to the 5 minus 2, which is 3 halves, plus 6 times 3 halves is 18 halves. X to the 3 minus 2, which is 1 half. And then minus 4 times 1 half is negative 4 halves. X to the 1 minus 2, which is negative 1 over 2. So G prime of x is 15 over 2, x to the 3 halves, plus 18 over 2, which is a 9, x to the 1 half, and a minus 4 over 2, which is minus 2, x to the negative 1 half. The negative 1 half power we can move to the denominator and rename it a positive 1 half power. And next to the 1 half is x to the first power and then second root or square root of x. let's rewrite the first term exactly as we have it. The second term, instead of x to the 1/2, the square root of x. And the third term, instead of x to the 1/2, the square root of x. And there's our derivative. Notice that matches exactly what we had produced in part A.